Okay, in this video we're talking about 2021 paper 2 question 5. Essentially it's all about area, volume and measurement. We have a sphere, and inside the sphere we have two cones. Essentially the flat part of the cones meets in the middle. We're told that the cones fit perfectly inside the sphere. In other words, the tip of each cone lies on the edge of the sphere, and the sides where they meet, that circle is also along the edge of the sphere. We're asked to prove that the remaining space that's not taken up by cones is half the volume of the sphere. Or in other words, that the two cones take up half of the volume of the sphere. Now, what you need to consider here, well, first of all, let's start off. We'll say that R refers to the radius of the sphere. And the radius of the sphere is from the center of the sphere to the edge of the sphere. If that's the case, then we go to our maths tables. The formula for the volume of a sphere, I have a Vs there to represent the volume of the sphere, and Vc here for the volume of the cone. The volume of the sphere, according to the maths tables, is 4/3 pi r cubed. And I'm going to leave it in that form because I want to get the volume in terms of r. But now it's important that you recognize what's going on with the cone. Let's just think about the cone at the top. The top cone, which is probably the easiest one for us to explore. The radius of the cone refers to from the center of the base to the edge of the base, and obviously that is the same as the radius of the sphere. So r for the cone is the same as r for the sphere. It's the h that you just need to focus on. You should see that the height, the h refers to this distance from the center of the base to the tip of the cone. That's what the h refers to. But obviously, from the center of the base to the tip of the cone is also from the center of the sphere to the tip of the sphere. Or in other words, it's also a radius. So the height of this cone is the same as the radius of the cone, which is the same as the radius of the sphere. So in fact, we could refer to the height as r, where we originally said that r represents the radius of the sphere. If that's the case, let's just imagine what happens when I'm trying to find the volume of the cone. It's just 1/3 pi, and r squared, I'm going to leave r squared as it is because the radius of the cone is the same as the radius of the sphere. But instead of a h, I can sub in r, because the height of the cone is the same as the radius of the cone. If I simply multiply my r's there, the volume of the cone is 1/3 pi r cubed. Now you should recognize that there are two cones. There's a cone on the top and there's a cone on the bottom. If the volume of one of the cones is 1/3 pi r cubed, the volume of both of the cones is 2/3 pi r cubed. And from there it's relatively clear. The volume of the sphere is 4/3 pi r cubed, while the volume of the two cones is 2/3 pi r cubed. So if I subtract the volume of the two cones from the volume of the sphere, essentially it's just 4/3 minus 2/3. You'll end up with 2/3 pi r cubed. The remaining volume, when you get the volume of the sphere and you subtract the volume of the two cones, is 2/3 pi r cubed, which is obviously half of 4/3 pi r cubed. And that's all I needed to prove. So I could conclude and say, right, well, the volume of the sphere multiplied by half, that's 4/3 pi r cubed by a half, which leaves me with 2/3 pi r cubed, which is obviously the same as what I got when I subtracted the volume of the cones from the volume of the sphere. So happy days, 2/3 pi r cubed, 2/3 pi r cubed. It's obviously true. In A part 2, we're told that the combined volume of the two cones is 686/3 pi centimeters cubed. In A part 1, we worked out that the volume of the two cones is 2/3 pi r cubed, where the r stands for the radius of the sphere and the radius of the cone and the height of the cone, because they're all the same thing. So all we need to do here is solve for r. And that's because the question said find the radius of the cone, which is also the radius of the sphere and the height of the cone. So we just need to solve it. We can let the volume we worked out in part I equal to the volume we're given in part II. The first thing I did was divide both sides by pi, so the pi's are gone. Then I multiplied both sides by 3 so that the fractions are gone. I'm left with 2 r cubed equals 686. Divide both sides by 2 and you get r cubed equals 343. And if you get the cubic root of both sides, you end up with r is equal to 7 centimeters. In part B of this question, we're told that at 9 AM a van leaves a factory. and it travels an unknown distance at a constant speed of 60 kilometers per hour. So obviously we're talking about distance, speed and time here. So I decided to set things up. I said, right, well, the distance is d, I don't know what it is. The speed is 60 kilometers per hour, and I'm not sure about time yet. We'll talk about that in a moment. We're told that an hour and 45 minutes later, another van leaves, van number 2. The only thing that we know is that it travels the same distance. It's going to the same place. Its speed is 95 kilometers per hour, and it arrives at the same time. So because it arrives at the same time, that's the key that's going to allow me to solve this question. First thing I'm going to do is, obviously it takes van number 1 a lot longer to reach its destination than van number 2. So what I'm going to do is call, let's say capital T is the time that it takes van number 2 to get to its destination. And let's see then, how long does it take van number 1 to get to its destination? Van number 2 left the factory 1 hour and 45 minutes later than van number 1. Or in other words, the time it took van number 1 to do the entire journey was T, this time, plus 1 hour and 45 minutes. Now just one thing you have to be careful of here, we don't want to write 1.45 hours. We want to figure out what proportion of an hour is 45 minutes. You can probably do that in your head. 45 minutes is 3/4 of an hour. Or in other words, 1 hour and 45 minutes is 1.75 hours. So if van 2, if it took it, this T is the length of time it took van 2 to get to its destination, the other van it took a T plus 1.75, or in other words, plus 1 3/4 of an hour. Now I can come up with an equation. I know that the distance for van number 1 is equal to the distance for van number 2. Essentially, that's going to allow me to work out the length of time. Remember what you learned, and you may not have even looked at it since junior cert, your distance, speed, time triangle. This is probably the way that you would have seen it before. If you want speed, you cover speed. Speed is distance divided by time. If you want time, you cover time. It's distance divided by speed. If you want distance, it's speed multiplied by time. In this case, I want to work out the distances because I know the distance traveled by each van is the same. So the distance is speed multiplied by time. For van number 1, the distance it travels is 60 multiplied by T plus 1.75. Or in other words, it's speed multiplied by time, just S by T. And I know that the distance traveled by van number 1 has to be equal to the distance traveled by van number 2. The distance traveled by van number 2 is a speed by time. In this case, speed is 95, and the time we're just calling it a capital T. You'll notice here I've got one equation and one unknown. I'm just going to multiply this out and solve to find the value for T. Then I'll know how long it took for the journey, and then I'll be able to figure out what time they both arrived. So it's very straightforward here. 60 by T is 60T, 60 by 1.75 is 105. And the right hand side is already 95T. When we solve this, we end up working out that T is equal to 3. And remember, the units we're looking at here are hours. So T is obviously 3 hours. Now, you just have to be a little bit cautious about your answer here. That means the length of time it took van number 2 to get to its destination is 3 hours. We know that van number 1 left at 9 a.m. So that means that van number 2 didn't leave until 10:45. So let's just consider this. Van number 1 left at 9 a.m. 1 hour and 45 minutes later, van number 2 left. So van number 2 obviously left at 10:45 or a quarter to 11. It took van number 2 3 hours to reach its destination. So if I just add 3, then obviously you could do it like this. You could say, well, it's obviously 13:45 p.m. Or in other words, van 2 arrived at its destination at a quarter to 2. Van 1 arrived at the same time. We know they both arrived at the same time, so that's our final answer.